Today we're going to be talking about adding and subtracting rational expressions. And this can be a little bit tricky, but hopefully after this lesson you'll understand it a little bit better. So remember, when they have the same denominators, that you just add the numerators and keep the denominator. Same with subtraction. Sometimes when it gets a little tricky with the subtraction, you can convert it to plus, negative. And then that makes it a little easier. Okay, so the next part, it gives you some steps to look at for finding the denominators if they are unlike denominators. So we're looking for what's known as the lowest common denominator. And the lowest common denominator is found, and it depends differently depending on what the denominator is. So for the first type, for integer values, like let's say you were adding 1/6 and 1/8. So you wanted to know the lowest common denominator between 6 and 8. So what I start to do is you're looking for the lowest common multiple of 6 and 8. So start with 6 times 2. 12 is a multiple. Is 8 times anything equal to 12? No. 6 times 3 is 18. Is 8 times anything equal to 18? No. 6 times 4 is 24. Is 8 times anything equal to 24? Yes, it is. 8 times 3 is equal to 24, so your LCD is 24. So in this case, you would multiply the 6 by 4 over 4 and the 8 by 3 over 3, and you can then see your denominators would be the same. We will, right now we're just focusing on getting the lowest common denominator. Now let's say you have a monomial variable in your denominators. So what you want to do here, so let's say you had like 1 over x squared plus 1 over x cubed. So what you want to do there is just look at between x squared and x cubed, you want to use the one that has the largest exponents. So the LCD would be x cubed. So we'd multiply by 1 over 1 and x over x so that the denominators are the same. And another kind is where you'd have binomials or trinomials that would have been factored. And what I look at in this case is what they have in common times what is not in common. So let's say, for example, you had 1 over 2 times x plus 1 plus 1 over 3 times x plus 1. Well, they have x plus 1 in common, but they do not have the 2 and 3 in common. So this side needs to be multiplied by 2 over 2 and this side by 3 over 3. So in this instance, the LCD is what they have in common times what they do not have in common, which is 6 times x plus 1. Okay, so to practice finding the LCD, let's take a look at the problems below. All right, so to find the common denominator here, first we should factor on number 1. I can't tell what the LCD would be. So GCF 4, and then you're left with x plus 2y. And then for the second fraction, 3 GCF, and you're left with x plus 2y. So they have x plus 2y in common. So what do they not have in common? The 4 and the 3. So the LCD is 4 times 3 times x plus 2y. What they have in common, one of them, times what they do not have in common, which is 12 times x plus 2y. For number 2, they have nothing in common. you might think they have a 3 in common, but this is a little monomial, and this y minus 3 is a binomial. There is nothing you can multiply the 3 by so that it would become y minus 3. If you multiply it times y, it becomes 3y, not y minus 3. So in this instance, the LCD is the product of what's not in common, which is everything. So 3 times y minus 3 times y plus 4. On number 3, look, x minus 8 and x, you might think because they have an x they have something in common. But here again they have nothing in common. So the LCD is x times x minus 8. On number 4, again I can't tell unless I factor, so two numbers that multiply to negative 15 and add to negative 2. So let's see, negative 5 and plus 3. And two numbers that multiply to 10 and add to negative 7. So that would be negative 5 and negative 2. So what they have in common is x minus 5s times what they do not have in common. So it's x minus 5, one of them, times x plus 3 times x minus 2. And again, we will actually go through the process of adding fractions on the next page. For number 5, I believe this is supposed to say x squared, so put a little power there of 2. So that factors to x minus 2 and x minus 2, and this is a difference of perfect squares, so x minus 2, x plus 2. So what they have in common times what they do not. And they have the x minus 2 in common, and they have x minus 2 over here by itself that's not in common, and then x plus 2. So there's the LCD, or you could write it as quantity x minus 2 squared times x plus 2. That's fine also. Number 6, they have monomial denominators. So between the 4 and 5, they have nothing in common, so it's just the product of the uncommon values. So the LCD would be 20. And then look for the largest exponent power. So x cubed, y cubed, z to the 4th. All right, let's go to the next page. So now we're going to actually add some of these together. Now 1 and 2, if you look, have identical denominators. So we do not need to worry about finding a lowest common denominator because they already have it. So just add the numerator and keep the denominator. So you get 2x squared plus 2. The thing you need to look at here, though, is what list the values that the variable would have for the fraction be not defined. There aren't any values that would make this fraction undefined because there's nothing you can plug in for x so that it would be negative 1 to make the denominator 0. So there's no values that would make this undefined. So all we have to do is simplify it, factor out a GCF of 2, we get x squared plus 1, and those cancel, leaving us with an answer of just 2. Number 2, we're just going to have to deal with the subtraction sign. So I'm going to make this plus, negative, negative. So what I have in my numerator now is a plus 4b plus 4a minus 7b minus 3a. You could put plus if you want, negative 3a minus negative b really turns into, and this is all over, a squared minus b squared, because that's, you know, the common denominator. But this really turns into plus positive. So now all we have to do is combine like terms. So we have a plus 4a, which is 5a, minus 3, which is 2a, and then 4b minus 7b is negative 3b plus 1b is negative 2b. And that should be over, and I can see I'm going to have to factor, so I'm just going to do a minus b times a plus b. That's a difference of perfect squares, and take a factor of 2 out of the top. And in this problem, a cannot equal b, otherwise the fraction would be undefined. And then the a minus b's cancel, so these fractions added together are 2 over a plus b. Now you're not going to always get situations where they simplify, just so you're aware. Number 3, okay, now monomials. So we're looking for the highest exponent. And then between the 4 and the 3, the LCD should be 12. So I need to multiply, so my common denominator is 12. A to the 4th, b to the 2nd, c d squared. Because I'm looking at, between the two of them, taking the largest exponent with the variables. So to make this right-hand one say 12, a to the 4th, b squared, c d squared, we need to multiply by 4 over 4. It has enough a's, it has enough b's, it needs a c, and it needs a d, because this one has a d squared. And on this side, we need to multiply by 3, and it needs an a, it needs another b, has the c, and it has the d. So 3ab over 3ab. So when we do that, if you multiply this out, you get 12 a to the 4th, b squared, c d squared. And so we have 3ab over that, plus multiply these, 8cd over this should be the same denominator. 12 a to the 4th, b squared, c d squared. Identical, then just combine those numerators. They are unlike terms, over 12 a to the 4th, b squared, c d squared. You cannot do what we consider chopping and like cancel anything further. There's have to be able to divide all of them by something to cancel further, or do some GCF factoring, and we can't do that. So that one's done. Oh, and in this case, A, B, C, and D cannot equal 0. Number 4, all right, so let's factor that denominator, x minus 1, x plus 1. And 2 times x plus 1. So here we're looking at what they have in common times what they do not. So they've got the x plus 1s in common. So this side needs an x minus 1. Now this one needs a 2. And now look, the denominators will be the same. So then we're going to distribute. And so we'd get 14 over 2 times x minus 1, x plus 1, plus x minus 1 over 2 times x minus 1, x plus 1. So using the commutative property of multiplication, I can write it like that. And then combine. 14 minus 1 is 13 plus x, all over 2 times x minus 1 times x plus 1. You can leave it like that, or you could write this as 2 times x squared minus 1. The values that x cannot be are 1 and negative 1. That would make it undefined. Okay, sliding down to example number 5. If you have a situation where the variable, the binomial, has 2 minus signs and they're in reverse order, you can use this little trick of multiplying by negative 1 over negative 1. Watch what happens. So I've got 2b squared over b minus 3 plus negative 18 over, now if you take and distribute this, you get negative 1 times negative b. Well, that's positive b, exactly what you had in the first fraction. And take negative 1 times 3, minus 3. So now you've got identical denominators. You do not need to multiply this by b minus 3.
The next portion of our staff development day is upstairs in B.
Okay, so now we have 2b squared minus 18. Sorry for that interruption. All over b minus 3. Let's see if we can factor further. 2 times b squared minus 9. Yep. And then a little bit more. 2 times b plus 3 times b minus 3 all over b minus 3. And so b cannot be 3. That would make it undefined. And the final answer is 2 times b plus 3. Or you could have 2b plus 6. On number 6, again, multiply by negative 1 over negative 1. And you get 4x over x squared minus 4 plus negative x minus 6, distributing that negative 1, over, now multiply these together and it converts that negative x squared to positive and the 4 to become negative. So the denominators are equal. Combine, you get 3x minus 6 because 4x minus 1x is 3x. And factor. So take out a 3, x minus 2. This is a difference of squares. So we get 3 over x plus 2. And x cannot be 2 or negative 2. All right, let's go to the next page to do a couple more of those. Let's take a look at number 8. I'm going to leave number 7 for you to try. So let's factor. So r minus s times r plus s, difference of perfect squares. Write this one out twice. You do not distribute that squared. And look at what they have in common. And this one has an extra r plus s. So this one needs one of those. So it needs an r plus s. So you have to do a form of 1. And this right-hand side needs the r minus s. So then we're going to do some distributing. But notice there's a subtraction sign here. So I'm going to convert that to plus negative 2. So I'm distributing a negative 2, keeping it all as addition. So I have 5r plus 5s. And then that's all over. I'll just write this as r plus s squared times r minus s. And this one becomes plus, we've got negative 2r plus 2s when we just do that distributing. And in that denominator, same thing, r plus s quantity squared times r minus s. So now just combine your like terms. The r's become 3r. And the s's become 7. Should become 8s. So I have, yours is a 3 here, sorry. So this is 3s. So this becomes 8s. And that's all over r plus s quantity squared times r minus s. You could factor, so this would be 3r here as well. I have a mistake, so hold on a second and let me erase that and correct that. Because that affects this down here. This is wrong. 5 minus 3 would be 2r plus 8s. Okay, so we're human, we make mistakes, sorry about that. Now, you could factor out a 2 in the numerator, but it's not going to simplify the denominator, so there you go. And r cannot equal s because of the r minus s. All right, and let's take a look at, let's do number 9. Okay, last one. So x minus 1 and x plus 1 for those factors. And I'm looking for 2 that multiply to negative 3 and add to negative 2. So let's see, that would be 3 and 1. So it's minus 3 plus 1. So they have x plus 1 in common. So this one needs an x minus 3. And this fraction on the right needs an x minus 1. Remember, we're taking what they have in common times what they do not have in common. So they have an x plus 1 in common times x plus 3, which is not in common, times x minus 1, which is not in common. Okay, and so now the denominators are identical, and so then we're going to FOIL the numerators, change this to plus negative 4, and distribute. So x squared minus 3x plus 3x, maybe you recognize that as a difference of perfect squares, kind of backwards. And then that's all over x minus 3, x minus 1, x plus 1. But you notice that if they are identical, you could basically just say it's really over that just one time, because that's what you end up doing anyways, is writing it one time. And then this is minus 4x plus 4. You can do plus and negative if you want. That makes it easier. That's fine too. This negative 4 times negative 1 becomes positive 4. So then combine here. So we've got those 3x's canceling. So it's x squared minus 4x. And negative 9 plus 4 is minus 5, or negative 5 there. And I believe that cancels, or factors further, so that we can cancel some more stuff. So we get x plus 1, I believe, and x minus 5. Yep, they multiply to negative 5, add to negative 4. And look at that. The x plus 1s are going to divide out. So final answer is x minus 5 over x minus 3 times x minus 1. And again, x cannot be 3, 1, or negative 1 before we canceled. And that's that. So I'm going to leave 10 and 7 for you to try. Okay, thank you. Good luck.